Welcome to this explainer. Today, we are absolutely unlocking one of the most foundational aspects of Java programming, how Java package structure actually works. Whether we're trying to write beautifully clean code for a massive project, or maybe you're gearing up for a brutal technical interview, mastering Java packages is literally essential. Let's break down exactly what they are and how they function right under the hood.
Okay, let's dive into this roadmap. First up, what is a Java package? Then, we'll explore built-in packages, creating user-defined packages, importing and naming rules, access modifiers and security, and finally, compiling and directory structure.
So, Section 1. What is a Java package? Before we even look at the syntax, let's make sure we understand the real-world problem we're actually trying to solve here.
Think about it. How do you organize thousands of Java classes? Imagine you're building a massive enterprise software application. You don't just have 10 or 20 Java classes, right? You have hundreds, maybe even thousands. If you just dump all those files into one giant directory, it becomes an absolute nightmare. You can't find anything, and even worse, you're practically guaranteed to accidentally use the exact same name for two different classes, which will instantly break everything.
Well, that is exactly where packages come in. Formally, a package is a namespace that groups related classes and interfaces together to improve code organization, reusability, and security. But honestly, just think of it like the physical file folders right there on your computer. You wouldn't throw every single document directly onto your desktop, would you? No way. You create a finances folder, a photos folder, a work folder. Packages do that exact same thing for your code.
So the crucial point is that packages aren't just a friendly suggestion, they are a vital structural tool. When an interviewer inevitably asks you why do we use packages, this is your golden checklist. We use them to organize Java classes, avoid class name conflicts, which is a huge one, improve code reusability, provide access protection, and ultimately make our application so much easier to maintain over the long haul.
All right, Section 2, Exploring Built-in Packages. Let's shift gears from the concepts and look at the practical, out-of-the-box tools Java gives us natively.
Java actually comes preloaded with built-in packages. It's kind of fascinating how Java uses that same folder analogy to organize its own massive library of tools. If you need to handle reading or writing files, you look in java.io. Need database connectivity? You pull from java.sql. Or maybe you need a collections utility, a scanner, or a random number generator. That entire toolset is neatly organized right inside java.util.
Now, pay super close attention to this specific comparison because I promise you, this is a highly common interview question. Java.lang versus java.util. What's the difference? Well, java.lang contains your absolute core Java classes. It's so fundamental that Java automatically imports it for you. You don't have to lift a finger. But java.util, which holds utility classes like scanner or ArrayList, is not automatic. You must explicitly tell Java to import it.
Let's move right into our practical workshop segment with Section 3, Creating User-Defined Packages.
Creating your own package is essentially a super simple three-step recipe. Step 1. Create the package by writing package my package at the very top of your file. Step 2. Save that file in a physical directory called my package. Step 3. Use the package anywhere else by just typing import mypackage.student. And this brilliantly illustrates how incredibly simple the underlying syntax really is once you get the hang of it.
Now that we know how to build them, let's hit Section 4, Importing and Naming Rules, because the industry definitely has strict standards for this. To keep everything globally standardized, we have to follow these rules. Always use lowercase letters. Do not use spaces. Obviously, avoid reserved Java keywords. But here's the cool one. Package names are usually based on reversed domain names. So if your company website is company.com, your package would be com.company.project. It's just the standard way to ensure global uniqueness so nobody's code steps on anybody else's.
Now, what if you just really don't want to use an import statement at the top of your file? You actually have another option, a fully qualified class name. Instead of importing and just writing scanner, you can write out the full path, java.util.scanner. You're spelling out both the package name and the class name every single time you use it.
So, let me ask you a question to test our understanding of this whole namespace concept. Can two different packages have classes with the exact same name? Think about how that folder analogy applies here for a second.
The answer is an absolute yes. And this right here is the magic of packages. You might have a student class for your company's training system, and another completely different student class for a school app you're integrating with. because they live in different namespaces like com.company.student versus org.school.student, Java can easily tell them apart using their fully qualified names. Zero naming collisions.
Let's move to and see how this builds into our security guardrails in Section 5, Access Modifiers and Security.
Okay, I want you to really focus on this matrix for a second, because it determines exactly who gets to see your code. Think of packages as strict security boundaries. Look at the top row. If a class is public, it can be accessed from absolutely anywhere, even different packages. But look down at default. That's what happens when you don't write any modifier at all. Notice how the green checks stop at the same package column? The moment you try to access a default class from a different package, Java straight up blocks it. It's exactly how you hide the internal workings of your code from the outside world.
Finally, let's ground all this theory into physical reality with Section 6, Compiling and Directory Structure.
Remember that physical folder analogy from the very beginning? Well, here is definitive proof of how it maps out. When you declare a package inside your student.java file, that file literally must sit inside a physical directory with that exact same name on your hard drive. The package structure physically maps to your computer's directory structure, while your main.java file, which actually uses the student class, just sits outside of it.
And here is an incredibly valuable technical tip for when you are compiling from the command line. Instead of manually creating all these folders yourself, you can just use the -d.flag. When you type javec-d.student.java, the Java compiler reads your package declaration and automatically creates the entire required directory structure for you. It's a massive time saver.
But look, it's not all sunshine and rainbows. There are definitely risks here. For beginners, jumping between different folders and package structures can feel pretty confusing, and if you misspell a folder name or your incorrect package path doesn't perfectly match the physical directory, you will be hit with immediate compilation errors. Managing a ton of packages absolutely requires discipline and proper project organization.
Now, what's really interesting about this slide is how this quote perfectly cements our ultimate takeaway today. The import keyword is basically our bridge. It brings this whole concept full circle, letting us utilize the brilliant organization of packages and grab tools from other namespaces without typing out fully qualified names every single time. It keeps our code super clean and readable.
Which brings us to the very end of our journey today. You now understand the why, the how, and the strict rules of Java packages. You know how namespaces prevent collisions, you know the difference between lang and util, and you know how access modifiers protect your folders. So the only question left is, are you ready to organize your codebase and completely ace your next Java interview? Thank you so much for joining me for this explainer. Now get out there and start building clean, well-structured code.